This video provides an introduction to simple calculations that can be made on rasters using the Raster Calculator Tool in RAMP. It expands on a previous video where we introduced raster calculation in RAMP generally by using the raster math and the map algebra processor methods. And briefly also we looked at the Raster Calculator Tool itself. This video, however, will look at the Raster Calculator Tool in more detail. We're going to do this by example, by setting an objective to calculate the topographic position index of a terrain dataset. The topographic position index can be calculated using the locally spatial statistics for the mean, minimum, and maximum values within a localized area. It's calculated as the mean minus the minimum value divided by the maximum minus the minimum value, or the range. Let's start the Raster Calculator Tool. You will notice there's a function area for your calculation function and an area to define raster variables. So before we start, we need to define variables as rasters that can be used in the calculation. So we need rasters for the topographic position index that represent the mean, maximum, and minimum spatially localized statistics. If I go back to RAMP, I need to declare these rasters in RAMP itself before they become available to the raster calculator. So in this example, my terrain data set is my favorite terrain data set that has the pimples or pockmarks on top of the mound. To visualize this better, I've also generated a hillshade where you can see those pockmarks and also these rocky outcrops at the downward slope of the mound. We need to calculate the max, min, and mean. So we're going to do that using the local statistics tool, processor, and specifically the localized statistics method, which will generate all of the main statistics or spatially localized statistics for a data set. So we're going to choose the input raster, we're going to choose a kernel size of 9, and we're going to generate all of the statistics. So it's added all of these here, but we only really need the mean. We don't need the median. We need the max and min. We can get rid of the range, the standard deviation, the skewness, and the kurtosis. Let's render these now and see what they look like. And the minimum value. Okay, so we have the mean, the max, and the min value in a 9x9 spatially localized kernel that gives the statistics for that localized neighborhood. Let's open up the raster calculator now again, and sorry, that was the wrong one. Let's open up the raster calculator and now declare the values for max, min, and mean. So I just right click here and I'll add the mean, and I will call this mean, and I will add the min, and I will call that min. Whoop. And lastly, I will add the max. So what I've done here is I've selected each of the input raster datasets and declared them as variables, and I've called those variables mean, min, and max. And I've also said that they are floats. So there are two types of variable that you can define in the raster calculator. The first one is a float. This returns the value of a single cell in each of the rasters that it's enabled for. Alternatively, I can choose a kernel, and this returns multiple cells in a neighborhood, and you can define the neighborhood size here as well. We're going to look at using the kernel data type in another video. So we're going to concentrate on the moment at just using a single cell floating point value. Let's move over now to our calculation function. The function is written in the C# programming language, which is a Microsoft .NET framework programming language, and RAMP is built on the .NET framework. The most important thing to look at is the function name. This function must have public scope, be static, it must return a float, and it must be called calculate. You'll also know that as I was declaring the raster variables, they were being added automatically into my function signature. So this is where when I define my raster variables, this is where they go, and they get automatically added into there. It's important to note that the variable names have to be compliant with the C# programming language requirements for naming conventions for variables. So I can't have spaces or certain characters in there. If you're unsure about what makes a compliant C# programming language naming convention, look up the Microsoft documentation that explains that. Now that the raster variables have been declared and also added to my calculate function, I can use any of these values in my function code. So let's look at it again. To calculate the TPI, or topographic position index, I need to take the minimum value from the mean and then divide that value by the range, or the max minus the min. So let's implement that function now. So I'm going to declare a float called TPI, and it's going to equal the mean minus the min divided the max minus the min. Just double check that there. The mean minus the min divided by the max minus the min. That's correct. Now I've realized here that there is a problem with this, so I'm going to return the TPI, so I'm returning that from the function to the function caller. There's a problem with this. If my max minus min, if the max and min had the same value, that would be a division by 0, and that would cause an error. So I can deal with that in a couple of ways. I could either put a exception handler in place, so a try catch, and return the default value of the raster, and by default a raster's null value is -9999. So I can rely on that, or I could explicitly handle that incident to return something else if I wanted to. For the time being, we're going to leave the exception handler in there, and it's going to return the null value for a cell. For the sake of example, I'm also going to show you how you can define another function in here that is called by the calculate function. So let's do that. I need to define another public scope static function. This one's going to return a float, and what I'm going to do is I'm going to calculate the range. So it's going to pass a max value, and it's going to pass a min value, and this function is simply going to return the max minus the min. And instead of putting that here, I am now going to call my range function and pass the max and the min to it. I did this for the sake of example. So you can create any other function that you want within this code set, as long as the calculate function exists. So in this case, we're calling the range. Now, again, for the sake of example, let's assume that we need to take the absolute value of the return of these. So let's do that. We'll implement another function called absolute. And again, it has public and static scope. It's returning a float, and it's going to be called absolute. And it will take a value of float, and it will return the absolute value. And it's going to do this by calling the Microsoft.NET Framework's pre-built functions to do this. So that is the system namespace, the math subnamespace, and the ABS method. So I can call any method or function within the system root namespace because this is available to the raster calculator. Let's modify this function now to return the absolute value of the max minus the min, and we will also return the absolute value of the mean minus the min here. So this function looks like it's ready to go, and it's going to return the topographic position index for these three using the combination of those three rasters. Let's run it and see what happens. Okay, and it's returned the results. So let's have a look at the results. Here we go, that's what it looks like. Let's do a little bit of work now to clean this up and make it look better. What I'm going to do is I'm going to put a kernel around this that is going to smooth out this value, and then we're going to re-render it so that we can really see the TPI with a little bit more sense than the noisiness that's in here. So the first thing I'm going to do is I'm going to do a local statistic mean on this, and I'm going to use a kernel size of 15 on the calculation results input. So let's do that first, and let's see what it gives us. I'm going to render that. There we go, and I'm going to define some split points in here to make it clearer. Actually, let me clear those. I'll start here, here, and here. Okay, and so now my terrain is sort of classified using the topographic position index. So I'm relatively happy with this now, so I'm going to fill in some of the comment information. Calculates TPI. Today is the 28th of December, and the author is Ramp Guru. So I'm going to save this now that I'm happy with it. So I'm going to click the save button here, and it's going to ask me, well, where do you want to save it to? So I'm going to override the tests CS that I created before. And now that is saved. This means that next time I want to reuse this function, I can. So let's close down the calculator now and see what happens when I open it up again and open that function that I've saved. So let's start the raster calculator again, bring it over here, and let's open now that function that I just saved. Now you'll notice that it's automatically recognized that I have a series of input rasters that are required, and it hasn't yet populated them in here because I haven't fully declared them. But it has recognized that they're floats. So I need to define the mean, the min, and the max. And this function is ready to go. So that is done because when you save the calculator function, it actually inserts a little bit of metadata in there that allows you, that stores the information about what the arguments actually are. So let's quickly have a look at that so you know what to look for if, for example, you opened this particular calculator function in a text editor. So I'm going to open this now in Notepad. And we'll see the code here. And you'll notice that there is a line that's actually in this file that says do not delete. And then it says ramp.tool.kernel sizes is 000. That means basically that mean, min, and max are all floats. If they were kernels, and we look at that in another video, it would have the actual dimensions of the kernels stored in here. So I guess if you're editing your function file in a programming IDE such as Visual Studio, or indeed even in Notepad++, make sure you don't delete this line because Ramp likes to use that so that it can more handily be able to set up the calculator function for you. Once you've saved the calculator function, you can call it programmatically using the Raster Calculator processor here. This simply allows you to be able to execute this code from, say, a workflow or even at the command line. And you simply select your input rasters. So in our case, it was the mean, the max, and the min. I believe the min was declared before the max. Let's double check that by pulling up the thing. So it goes mean, min, and max. Okay, so that means I need to change the order of this. So the first was the mean, then came the min. So I'm going to put the min on top of the max, and now I have the mean, min, and max defined in that order. That's important because those are the input rasters to the function. And then I define the input kernel sizes. So those are 0, 0, 0 because they're floats. And then I point it to the function file, which was test. If I execute this, it now does exactly the same thing as what I've done using the Raster Calculator tool, but it opens up the possibility that I can execute raster calculations via a processor. So that's been a quick introduction to the Raster Calculator tool, and I just wanted to add one more thing to this, and that is people have asked, can you execute can the Raster Calculator execute functions that are in other libraries other than what's in the system namespace that we looked at before? And the answer is yes. And the RAMP documentation for this shows you how to do that. So let's have a quick look at that. So here in the Raster Calculator help documentation, there is a section called Calling an External Library. To do this, you need to use something else that's in the system namespace, and that is using reflection. That means you essentially load a library, a DLL library from a particular path. You define the namespace that you're interested in accessing within that library. You create an instance of that namespace. You access the specific method within that namespace that you've defined. Then you define the parameters for that method, and then you invoke or execute that method. So this is a little bit more of an advanced thing that you might want to do inside your calculator function, but there are some cases where you might want to call a specific library that does some specific sort of function or calculation for you, and this is how you do that. So anyway, this has been an introduction to how to do calculations on rasters, and we've looked at everything from really basic techniques to something that's more complicated. So I hope this has been of help to you, and in the next video we're going to look at how to do something a little bit more complicated, and that is using the kernel raster variable type in the calculator. So thanks for watching.